Hi, so sorry I couldn't be there today, so this was the best that I could do, unless Miss Novak's teaching. But if she's teaching, then you wouldn't be watching this. All right, so we are starting Unit 3 today on rational expressions and equations. And today we're just going to do the lesson for day 1, and luckily it's a short one, pretty straightforward, nothing too complicated. So hopefully it's a nice, easy one to learn from a video. So we're going to simplify rationals and talk about when is a rational undefined. So a rational number is pretty much like a fraction. There's a number on top, or maybe an expression on top that would represent some real number, and then an expression in the denominator that would also represent something. And A and B are going to be considered integers. So any of these expressions that we see and we call a rational is considered, we're going to call them some type of integer. So if you take any number, your favorite number, let's say 10, and you type it in your calculator and you divide it by 0, your calculator should throw an error. It should say error cannot divide by 0. And that's because it's something called undefined there. So what I'm going to be having you guys do today is determine what values of x or values of whatever variable we're using will force the rational to be undefined. So for something to be undefined again, we only care about the denominator being a 0. So rationals are undefined when the denominator is equal to 0. So that's what we're going to do. So when it says find all the values of x that make the fraction undefined, I literally take the denominator, whatever it may be, I set it equal to 0, and I solve for the x value that makes it undefined. So I would say in this problem that x cannot equal -2, because if I plug -2 in for x, oh, sorry, my pen's being weird, I get a 0. It's that easy to determine where something is undefined. And so half the time we're going to do it kind of like mental math. So this one, same thing. So we're going to set this equal to 0. I would divide by 16 on both sides. I don't know why my pen's being like this. And 0 divided by 16 is 0. Okay, sometimes we might have to factor to be able to determine all of the values of x that make it undefined. So if I set this denominator equal to 0, and I take a GCF out, so in this case a 2x, and my remaining factor would be an x minus 3. Not sure why my pen's still being like this. I would t-chart, and I would find that x cannot equal 0 and x cannot equal 3. So this actually has two values of x that would make it undefined. So that's going to come up later, especially when we start solving rational equations. That's going to be super important. For the rest of the lesson, though, we're going to simplify rationals. It's going to be tempting to want to kind of cancel everything out, but you are not going to be able to just cancel crazy. So when can you cancel? You can only cancel when factoring is involved. So it has to be multiplied by something. If you see a binomial or a trinomial, it might need some factoring if that's possible, but I'm going to put parentheses around any binomial that I see. So any of the binomials that you see, put parentheses around it, because that is its own integer. You cannot break up a binomial like that. So I put parentheses around it, and I think of it kind of like a hug. So you're not going to break up those sets of parentheses. So when you look at letter A, we have 2x divided by x. There is multiplication. Oh, I should also put when multiplication is involved. Because in letter A, we have 2 times x divided by x. Just using our knowledge of our exponent rules, we know that those x's will cancel each other out, and this will reduce to 2. Again, I don't know why my pen is being so fussy today. Oh, that didn't help at But in letter B, you are going to be totally tempted to cancel out those 10s, but you cannot. X plus 10 is its own number, and then the 10 in the denominator is its own number. You cannot cross out those 10s. This actually is as simplified as it can possibly be. Same thing in letter C. I can't cross off those A's. I can't cross off those B's. This is as simplified as I can possibly get it. This would be done. But if we look at letter D, notice that I have the factor x plus 2 on top, and I have that same factor in the denominator. Those I can cross out, and my final result would be x plus 1. That's because not only was factoring involved, but multiplication was involved. Letter E, x plus 3 divided by 3 plus x. I hope that you agree the commutative property of addition tells you that those are the exact same thing. So if they cancel out, no, they don't equal 0, they equal 1. In letter F, you're going to be tempted to cross out the 12x's, but I hope the fact that you put parentheses around these factors means you cannot simplify them unless they are absolutely identical. And 12x plus 1 is not the same as 12x minus 5, so that's as far as you can go. Lastly, letter G, I have this 4 factored out as a GCF in the denominator, so 4 goes into 12 3 times. And that is as factored and as simplified as we can possibly go. All right, so how do we simplify a rational expression? Those are some examples of when can you and when can't you. So let's actually do a couple examples of how to simplify a rational expression. What we're going to want to do is factor first to the best of our abilities. And so we might need to do GCF. A lot of the time it's GCF. We might have to do some dots. Oh my God. My pen is being so touchy today. Trinomial factoring, so double bubble. Ignore my spelling. I swear I'm spelling things right, but my pen is not being very forgiving. We might have to do grouping. And so on. Soap, probably not, but maybe a little bit. All right, so let's take a look at the first example. If we can do any factoring. And I notice in the numerator that there's a GCF of a 5. So I'm going to factor a 5 out, and I'm left with a D minus 3. And in the denominator, I can factor out a D. And what's remaining left after that is a D minus 3, which is super nice. Because now I notice this D minus 3 and this D minus 3 are the same. And so my final answer would be 5 divided by D. All right, in number 2, I noticed that the denominator has an x plus 4, so I'm going to put parentheses around that. And my numerator, I'm going to try and double bubble factor it. Oh, I'm not going to jinx it, but my pen looks like it's working. Okay. The top, we want to find things that multiply to 28 but add to an 11, so hopefully everybody's thinking what I'm thinking. 7 and 4. And just like that, my 4's match, and my final answer would be x plus 7. Hopefully this is making sense and I'm not going too fast. All right, we always want to look for factoring first. I notice a 2 GCF in the numerator, so I'm left with an m minus n over an n minus m. We have not had this conversation yet, so let's talk about it. Okay, so m minus n that you see in the numerator looks very similar to what's happening in the denominator. However, if I just pick 2 different numbers, I'm going to change my color just so we don't get confused. If I just pick 2 numbers, any numbers, literally any numbers in the world. Let's say I pick 5 for m and 2 for n. And like I said, I'm just picking random numbers. If I plug those in for m minus n, I would get 5 minus 2. And the denominator n minus m, I would get 2 minus 5. And what I notice is 5 minus 2 is positive 3 on top. In the denominator, I get negative 3. and that simplifies to -1. Okay, maybe that was just a coincidence. Let's see if it's the same if I pick different numbers. So if I erase those, let's try it again with other numbers. All right, so let me pick my green again. All right. Let's pick 15 and I don't know, 5. Sure, 15 and 5. So m minus n divided by n minus m. Oops, I wrote n instead of the number 5. That should be a 5. So 15 minus 5 is 10. 5 minus 15 is -10. And again, the result comes out to be -1. So if you keep trying different numbers and keep trying different numbers and keep trying different numbers, literally the same result happens every single time. And so what we can then kind of come up with is the fact that if we see two factors that look almost the same, but they're flip-flopped and they have a minus sign between them, they cancel each other out and create a -1. So what my final answer for this problem will be 2 times that -1, so my final answer will be a -2 for this problem. But that relationship of m minus n, or if the two factors look the same, they are just like the flip-flop of each other, we're going to get a -1. All right, moving on to number 4. I know that means you guys probably have to flip the page, but I noticed the numerator has a GCF. Denominator also seems to have a GCF. And let me pause there for a second. Is there more factoring that I can do? I notice that I have a y squared minus 16 in the denominator, so I'm going to factor that one more time to be y plus 4, y minus 4. All right, so we can only cancel things if multiplication is involved, and we have the same factor on top and the bottom. So I can't cancel anything if they're next to each other, but if I have something on the top, like y minus 4 and y minus 4, those two can cancel each other out. And I actually can cancel out the y that's here in front of the, with the coefficient, and the y in the denominator, because those are the same factors. And so in the numerator, I'm left with a 3. Oh, I meant to change that to blue. In the numerator, I'm left with a 3. In the bottom, I'm left with the y plus 4. And that would be my final answer. My pen's getting back to being weird. Ooh, I do have to do soap. All right, here we go. So the numerator's a soap situation. So my a will be 3x. And my b will be 1. All right. So soap is a binomial times a trinomial, and my pen is being annoying. Let me make my cursor a little bit smaller here. Okay, same sign. Opposite sign, always positive. Bear with me as I try and squeeze these things in these spots. All right, my a is 3x. My b is a 1. So my a squared is going to be a 9x squared. My b squared is a 1, and my a times b is a 3x. All right, not too bad. My denominator has a GCF of a 2, so I'll take that out. Cool. That cancels out that. Oh, yellow's not easy to see. There you go. That cancels out that. And so my final answer, my pen will write nicely, is 9x squared minus 3x plus 1 all over 2. All right, a couple more examples here. Number 6, I have 4 terms in the numerator. Literally the only thing I know how to do with 4 terms is factor by grouping, so that's what I'm going to do, group and group. So my first two have a GCF of an x squared. My second two have a GCF of a 4. Alright, so my numerator's factors look like it's x squared plus 4 and x minus 5. And my denominator looks like it has a GCF of an x, so x minus 5 is the other factor. X minus 5's go away. I think that's the obvious one. Now, if I rewrite what I have left, x squared plus 4 divided by x, I'm worried that some of you are going to want to cancel out the bottom x with the x squared on the top. You cannot do that. X squared minus 4 is its own factor, it's its own number, it has its own value and identity, so you can't cancel those x's. Okay, and I'm probably going to stress that for the rest of this unit. But if I have parentheses around it on the previous step, I strongly encourage you keep those parentheses around it on this step, because hopefully that will be a big indication to you that you cannot cancel those x's out. So this would be as far as you can go. Oh, and if you're thinking dots, you can't do dots on this one because it's plus sign. All right, 3 more examples. And then I can go to bed. I see dots on the top of number 7. So if the number comes first, the number has to come first. And the denominator looks like multiplies to 8, adds to 9. So 8 times 1 multiplies to 8, adds to 9. They both have to be positive. Okay. So something's going on with these two. And this is where you have to ask yourself, do they cancel out completely and just make a positive one? Or do they cancel out and make a negative one? So bear with me for a second as I scroll up. In this example over here, I wish I could find my highlighter. I thought there was a highlighter somewhere. Oh yeah, highlighter, haha. Okay, let's see. In example E here, I don't know if you can see that, whatever I just did. If you can look at example E that's on the screen over here. This we had x plus 3, 3 plus x, and we canceled them out and just made it a positive 1. But over on example 3 over here, we had an m minus n and an n minus m. If there is subtraction involved and they are flip-flopped of each other, that cancels to a negative 1. So if we go back to the example that we are on, 8 plus c and c plus 8, that is just the commutative property. That means that those are completely equivalent to each other. So I can just cancel them out and it would technically make a 1, and you don't have to write anything for it. So your final answer would just be the other two factors. All right, number 8, the numerator has a GCF. Pretty easy. Denominator is double bubble. Okay, I think there's a better side of this pen than the other, so I have to stop rotating it. Multiplies to 18, adds to negative 3. So 6 times 3 is 18, a negative 6 and a positive 3. The obvious ones are a plus 3 and a plus 3. Those are easy. What I'm worried about is you're going to want to cancel those a's that are left. You cannot. Oh, I forgot to change it back to blue. I have an a left in the numerator and an a minus 6. Keep the parentheses around it. You can't break up those parentheses, so hopefully if you leave them there, you won't do it. All right, last but not least, we have a SOAP in the numerator. So all of the x cubed minus 2 cubed. We have same sign, opposite sign, always positive. If my a is x and my b is 2, then I have x, or a squared, b squared, a times b, and obvious what you're canceling. All right, and that's day 1 notes. I'll see you on Monday.